Two-dimensional arrays. A one-dimensional array stores a list of elements. A two-dimensional array can be thought of as a table of elements with rows and columns. To be precise, in Java, a two-dimensional array is an array of arrays. A two-dimensional array is declared by specifying the size of each dimension separately. So here's an example of a two-dimensional array being declared. So you use two square brackets and then you use the size inside the square brackets. An array element is referenced using two index values. So if you wanted to reference a value in a two-dimensional array, now you have to use two indexes, one for the first dimension and one for the second dimension. The array stored in one row can be specified using one index. So here they're saying if you have a two-dimensional array and the name of that variable is table, table references that 2D array, while table at some index references an array of integers, and then table with two indexes will reference that one integer at that one spot. See 2D array in Soto survey. Here's the class 2D array. They declare a two-dimensional array and they use a reference variable table. They have a for loop and they're iterating over what they call the rows. So this is going to be the first iteration of the outer array. So this is going to go 5 times. And then inside of that loop, they have another for loop that's going to go into the columns. This time they're getting the length of the array, which is going to be 10. So they're going to execute this 10 times. And they're simply just adding in values to this two-dimensional array. And then they're printing out the table. And here's what the output looks like. So you have your rows, 1, 2, 3, 4, 5. And then you have your columns, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is a two-dimensional array. So just think of it as a table. In the next example, called Soto survey, they have a two-dimensional array. But this time what they're doing is they're using an initializer list. So if you look at this initializer list, there's an outer list, right? So here's the curly brackets here and here. And then for the second dimension, they're using initializer list again. So they're passing in these values here, but they're doing it 4 times. So this array has 4 rows and 10 columns. Then they have a constant called sodas, which is the length of the first dimension. So this is going to be 4. And then they have a constant called people, which is going to be the length of the second dimension, which is going to be 10. And then they make 2 one-dimensional arrays for the sodas and for the people. Then they iterate through their list of sodas. And the list of sodas is being based off this variable here, sodas, which is essentially just the size of the outer array, which is 4. Then inside of that loop, they're going to go into another for loop, but this time they're calling it people. Now remember, people is the inside array, which is the length of the second dimension, which is going to be 10. And they're taking those values and they're setting their arrays for the soda sum and for the people sum. Then they create a decimals formatter, they create an average, then they iterate over their soda array and their persons array, and this is what they get. Now I'm not really familiar what this data actually represents, but this example was just a little confusing because you had 3 arrays. You had a two-dimensional array, and then you had an array for soda sum and for people sum. And essentially what they're doing is they're diving into this multi-dimensional array and they fill that information by iterating over their two-dimensional array. An array can have many dimensions. If it has more than one dimension, it is called a multi-dimensional array. Each dimension subdivides to the previous one into a specified number of elements. Each dimension has its own length constant. Because each dimension is an array of an array references, the arrays in one dimension can be of different lengths. These are sometimes called ragged arrays. All right, so to better explain the arrays, so here is an example of what an array looks like if it was one-dimensional array. So this is a one-dimensional array with a size of 5. So it has 0 through 4 indexes. You essentially store one row of data. Now a two-dimensional array will look like this. I said the first dimension is 3, the second dimension is 4. So here's my first dimension, which is essentially just my rows, 0, 1, 2. Then my second dimension is my columns, which is 0, 1, 2, and 3. Now let's just say I had a value inside of this two-dimensional array, and that value is 9, and it's located right here. Now if I wanted to reference this value, I would have to use the name of my array, which is R2, and then I need to specify the index of where it's located. The index of where 9 is located is at index 1 and index 2. So this is where the first dimension goes. This is where the second dimension goes. This right here will give me the value 9 because 9 is stored at this index. Now you could have multiple dimensions of an array. You can have a third dimension, and this is what a third dimension would look like. All right, so here's an example of a 3-dimensional array now. This is a little crazy, I know. It was difficult to draw. But here is the first dimension, 0, 1, and 2. I said the first dimension is size 3. The second dimension, I went ahead and put the numbers on the bottom just so it could look a little nicer when I made the third dimension. So right here is the second dimension, 0, 1, 2, and 3, and that is of size 4. So I have 4 possible values. The index starts at 0 and ends at 3. Now the third dimension is specified right here. This is like our depth, right? So this is the row, this is the column, and this is the depth. It's of size 5. So I start off at index 0 and I go to index 4. Let's just say this cube right here that I highlighted in green is what I want to reference. And let's just say it has the value 3 inside of it. Now if I wanted to reference this value, I'd use the name of the array and I'll specify the indexes to get to this point. So this location, this cube right here, if I were to pull it out, it actually looks like this. And there's a 3 that exists inside of this little block. So the first dimension would be at index 1, the second dimension would be at index 3, and the third dimension it would be at index 2. So if I wanted to reference this value, I would have to do this. And this is what I would have to specify in my Java code in order to reference this 3 that's located right here. Now you can keep going with this. You can go to 4 dimensions, 5 dimensions, like there's no limit to this. So anything past the 3rd dimension is difficult to draw, obviously, but you can actually have a 4-dimensional array, 5-dimensional array. You can keep going and going with it. So I have a 2-dimensional array that is 3 by 3. Now I'm drawing this because I want to do the tic-tac-toe example. So if you're playing tic-tac-toe with your friend or your buddy, most people will start off by putting an X here. And then the next move would be the O, and they'll probably maybe put an O right here. And then the next person would go and maybe put an X here. O would make an attempt to block. And then X would try to do something like put something here, O there, and then so on. So we can play a tic-tac-toe game with the user by using a multidimensional array, which is 3 by 3. And we can use that multidimensional array and specify where the output's going to go. So I'm going to go ahead and do an example of this. Okay, so I made a project called Tic-Tac-Toe Demo, and I have 2 files in here. I have the game test, which is my driver class, and I have the Tic-Tac-Toe game. The Tic-Tac-Toe game is going to be my blueprint class for a Tic-Tac-Toe game. This is where I'm going to have the board, which is going to be a 2-dimensional array, and then I'm going to have some variables to track whose turn it is, and I'm going to have some methods that my driver class is going to use. Here's my game test. I have the main method, and I have a scanner object. I'm going to prompt the user to enter in which spot he wants to take on the Tic-Tac-Toe board, but I'm going to prompt him to enter a number for the spot. For instance, when I show the user the board, I'm going to ask him to pick a spot. And to pick a spot, I'm going to ask him to enter a number between 1 and 9. I'm going to show him the board, and the 1 through 9 is going to correlate with the spot on the tic-tac-toe board. Now, even though I know in my dimensions this is my row and this is my column, so really I should be taking in a 0, 1, or 2 for the row and a 0, 1, or 2 for the column. I'm going to ask him to enter in a number, and I'm going to translate that number into a row and a column. I think this is a more natural approach when presenting the user with the tic-tac-toe board of which spot he wants to take, and that's the way I'm going to make my game. So I'm going to go ahead and create some variables I need to manage this tic-tac-toe game. So one of the things I do need is a 2-dimensional array. It's going to be a 3 by 3. I'm going to make it of the char type. So here's what I have so far. I have my board, which is going to be a 2-dimensional array of the char type. I have my turn count. It's going to count what turn it is. So in a tic-tac-toe game, there's only really 9 turns. Once you get to the 9th turn, if nobody won, the game is over. And it declared some constants for X's character and for the O character in the max number of turns. So I'm going to create a constructor that's going to initialize the board, and it's going to put the characters in for each spot. So what I plan to do is instantiate the board to be a 3 by 3 char array. I'm going to put in a 1, 2, 3, 4, 5, 6, 7, 8, and 9 at each one of these spots. Well, I'm going to put them in as chars. So I'm going to go ahead and create my constructor. So here's my constructor. My constructor is calling this reset method I created. So I went ahead and moved all the logic to reset the game into a method called reset. The reset method is going to set the turn count to 1, and it's going to instantiate my 2-dimensional array by saying it's a 3 by 3 char array. Then I have this count variable. This count variable is going to keep track of my iterations. I'm going to increment my count instead of the most inner for loop. So I'm expecting this count to increment 9 times. I'm going to use the value of count to determine what value I'm going to put into my 2-dimensional array. My outer loop, I'm going through my rows. My inner loop, I'm going through my columns. So the very first iteration, R is 0, C is 0, and I'm placing in a char. So I'm taking the char value for 1, which is going to be the Unicode character set value, and I'm adding count to it. So count's going to start off at 0. So I'm basically adding 0 to the Unicode character value of 1, and I'm casting it to a char, and then I'm putting that into my 2-dimensional array. So this will go from 1 all the way to 9. But I'm putting the char value of the numbers and not the integer value. So now that I'm setting up my array, I want to go ahead and make a method to print out what the array looks like so that I'm able to display the board to the user. So now what I'm going to do is I'm going to go to my driver class and go ahead and print this out so I can see what it looks like. So in my driver class, I went ahead and instantiated a tic-tac-toe game. Then I'm going to display the board. So I'm going to go ahead and run this program. And here's my result. So I'm going to show the user the board with the numbers inside of it so that he knows which number to pick for that spot that he wants to take. So the next thing I want to do in my tic-tac-toe game is I want a method that can be used to set the spot that the user wants to take. So this method is going to take in an integer, and it's going to take that integer and it's going to set the correct spot. For instance, if the user enters 5, then this method is going to use 1, 1 to set the board at that location. If the user enters an A3, it's going to use 0, 2 to set the board at that location. So I'm going to go ahead and create that method. So here's my set spot method. I'm going to take in an integer, and I'm simply going to use a switch case. And depending on what value they entered, I'm either going to return take spot at 0, 0, 0, 1, 0, 2. It's all correlating to this value here. Anything that is not 1 through 9, I'm going to return false. So this method is actually going to return a true or false whether or not we're able to set the spot. Now I did make a take spot method, and here's my take spot method. It also returns true or false. It's going to take in a row and a column. So I'm doing a check to verify that the row and the column are 0 through 3, but I really don't need to do this because this is a private method and it only gets called within my class. So if it's getting called within my class, then I should be passing it the correct values. So I can remove this if I wanted to, but I'm going to go ahead and leave this in. So I check to verify that we're in range. Then I check to see if the board does not contain an X or an O at that location. So in other words, if there's already an X or an O, then we can't set that spot. So if this is false, then we're going to return false. We're never going to go inside of here. But if there is no X or O at that location, then we're going to come inside of here. We're going to determine our count. So we're going to take our turn count divided by 2. If it's 1, we know it's X's turn. Otherwise, it's O's turn. And we're just going to set the location with the char at that spot. Then we're going to increment our turn count. So this value is going to increment. So the next time we invoke this method, it's going to use the other character to take that spot. And that's pretty much it. We should test this, but I do want to say one thing. We can actually do a more programmatic way to determine what spot to take instead of just doing what we did here. If you look at the math behind this, you can actually do something like this. So this is what we can do. We verify first that S is within range 1 through 9. And then once we know that, we can take S minus 1, which is just going to be subtracting 1 from whatever the value is. So for instance, if they enter in a 1, the value would be 0. Then you're going to divide that by 3. Now the result of 0 divided by 3 is 0. The result of 3 divided by 3 is 0. And since this is all integers, we're not going to have any fractional parts. So if we take 1 divided by 3, that's still going to be 0 for the row and so on. So to explain this further, I'm going to hop back to the board. So in the logic I just created, I'm taking S minus 1, where S is any value between 1 and 9 for the spot they want to take. So if we redraw the value with S minus 1, so what we're saying is our row is going to be equal to S minus 1 divided by 3. Now because these are integers, there's no fractional part. So if we take 0 and we divide it by 3, we get a 0. If we take 1, we divide it by 3, we get a 0. We take 2 divided by 3, we get a 0. 3 divided by 3, we get a 1. Right? So these are actually correlating to the row numbers. 4 divided by 3, we get a 1. 5 divided by 3, we get a 1. Because remember, integers, the fractional part is left off. So we move down to 6, we get a 2. 7, we get a 2. 8, we get a 2. So this is how we would get the row number. For the column number, we're just going to use the remainder math. Where we say S minus 1, the remainder of dividing by 3 is what we're going to put for our column. So if we divide 0 by 3, we get a 0. There's no remainder. We divide 1 by 3, we get a 0. There's 1 remainder. We divide 2 by 3, we get a 0, and there's 2 as a remainder. So those values correlate to the column index. We could do the same thing for 3. 3 divided by 3, it's 1 with no remainder. 4 divided by 3, it's 1 with 1 remainder. 5 divided by 3, it's 1 with 2 remainder. So this is an easier way to calculate the row and the column. So if you come back over here, that's exactly what I did for my logic. But writing it with the switch statement isn't wrong. It just takes a little longer and it's more lines of code. So I'm going to leave all this commented out, but we're going to go ahead and leave this logic here. So now what I want to do is I want to update my driver class so that I'm actually prompting the user to enter a value, and then I'm going to prompt them to enter the value for O as well. So I'm not going to do any random generation just yet. So in the actual tic-tac-toe game, we're currently not doing anything to determine who the winner is. This game is never going to stop until the user decides he wants to quit. So I'm going to go ahead and put this logic in. So here's what I have. I created a variable to hold the user's option. I enter in a do loop, and I'm saying in this do loop while the option is not -1. So the user is going to enter in a -1 to quit. I'm going to display the game board. Then I'm going to ask him to enter in what spot number he wants or -1 to quit. I'm going to store that value into opt, and then I'm going to check to see if opt is not -1. And then I'm going to check to see if opt is a valid option, meaning the spot's not taken or it's within range. At this point, if the user decides to enter in a -1, then I'm going to quit. But once he enters a valid value, the loop is going to go ahead and run again. And this time it's going to be the O's turn. So it's going to go X, O, X, O, X, O. It's going to keep going. But at some point, we're going to get to the point to where there's no spots to take. And the only option is going to be for the user to enter -1 to quit. So let's go ahead and run this game. So here's my menu. I show the board. I'm going to go ahead and make sure that I can actually leave this game. I'm going to enter a -1 and the game finished. I'm going to run it again. This time I'm going to select 5. You can see that X took the spot in the middle. Now it's O's turn. And I'm going to enter a -1 to make sure that I can quit. Now the one thing I don't like about my prompts is that I'm not saying whose turn it is. I want to know if it's X's or O's turn. So I'm going to go ahead and update the tic-tac-toe game to return the char of whose turn it is based off the turn count. So I'm going to come to my tic-tac-toe game. I'm going to make a new method. So the method I made is called getTurnChar. It's going to return a char, and it's going to use a check to see if dividing turn count by 2 is equal to 1. If this is true, I'm going to return an X. If it's not true, I'm going to return a no. So I'm going to go ahead and use that method in my driver class so that I can alert the user whose turn it is. So I went ahead and updated my prompts. This time I'm using a printf and I'm returning out the turn char. And let's go ahead and rerun this game and let's see how far we can get. So here's my game. I'm going to go ahead and enter in an X, and it's actually telling me that it's X's turn. So I'm going to put in my X at spot 5. Now it's telling me it's O's turn. So O's going to take spot 6. Now X is going to take spot 1. O is going to take spot 3. X is going to take spot 9. And at this point, X has won the game, except I don't have any logic to determine who actually won the game, and I don't have anything in here to actually stop the game. So I'm going to go ahead and finish. I'm going to enter in a 2. Now I'm going to enter in a 4, a 7, and 8. So now the entire board is filled. The game should have ended here because there's no more turns to take. But I'm going to go ahead and enter in a value, say 3. So it doesn't matter what value I enter. The only thing I could do now is enter a -1 to quit the game. So there's a lot left to do to this class. So one thing we have to do is we have to determine if there's a winner after so many turns. So I believe it's on the 5th turn is when you should have a winner, because that's when the X can enter in 3 values. So on the 5th turn is when you should start checking to see if there's a winner. And the other thing we need to do is after the turns are over, after you reach your max number of turns, then the game ends and you have to end this game. But I'm going to leave all that logic to you. You're probably going to have to add in a few more variables here to make this work, and you're definitely going to need some more methods.